module of electrons and photons, and in this module we are going to learn about the explanation of characteristics of photoelectric effect with the help of Einstein's equation. So as we all know that Einstein was the one who gave us this photoelectric equation. The equation is as follows. It states that kinetic energy maximum is equal to h nu minus w naught. The same equation can also be written as half mv max square is equal to h nu minus w naught. Now you must be wondering how that equation becomes that, because we know that kinetic energy is equal to half mv max square, hence we can substitute the same over there and we obtain the following equation. We can also write the same equation in this format, that is EVS is equal to h nu minus w naught. Now my question is, how does kinetic energy maximum is equal to EVS? Students, we remember that work done is equal to Ke max to stop the electron, and that work done is given by EVS. That is why kinetic energy is EVS, and hence we get this equation. In this equation, Vs stands for stopping potential and E stands for charge of electron. Now on the basis of this equation, we are going to state the characteristics of photoelectric effect. And according to Einstein's photoelectric equation, that is h in bracket nu minus nu naught, which is equal to kinetic energy maximum. Now by looking at this equation, we can say that if nu is less than nu naught, that is the frequency being less than the threshold frequency, then the kinetic energy will become negative. Now if kinetic energy becomes negative, such a condition cannot be possible. So in physics, kinetic energy cannot be negative. That means, can I say, in this case, photoelectric emission will not take place. So photoelectric emission does not take place when frequency is less than the threshold frequency. So how will the photoelectric emission take place, or when will the electron have kinetic energy? Can I say the kinetic energy will have its positive value when frequency will be greater than or equal to the threshold frequency. So photoelectric emission will take place only when frequency is greater than or equal to the threshold frequency. So on the basis of this, what conclusions can we make? We can make the following conclusions. Conclusion number 1. If nu is equal to nu naught, that is if frequency is equal to the threshold frequency, then the electrons will be having their emission which will be taking place. But these electrons will not have any kinetic energy. Second conclusion, we concluded that if frequency is less than the threshold frequency, then photoelectric emission does not take place. Number 3, if frequency is greater than the threshold frequency, then the photons are emitted, that is photoelectric emission will take place, but also the electrons will have some amount of energy in the form of kinetic energy. Moving ahead to the next characteristics, according to Einstein's photoelectric equation, we know that h nu minus nu naught is equal to kinetic energy maximum. And as we go on increasing the intensity of light, we know that the number of photons striking the metal plate also increases. And if number of photons striking the metal plate increases, then the number of electrons also increases, and hence the photoelectric current increases. That means photoelectric current indirectly depends on intensity. That if the intensity goes on increasing, the photoelectric current also goes on increasing. So this explains the relation between them, which is direct, and hence we obtain a linear graph. Moving ahead, according to Einstein's photoelectric equation, we know that h in bracket nu minus nu naught is equal to w naught. That means as soon as when the radiation is incident on the photosensitive surface, there is a collision which occurs between photons and electrons, and as soon as that collision occurs, the electrons are emitted from that plate. So emission of photoelectrons occurs as a result of collision between photons and electrons. So can I say there is no time lag between them, and since there is no time lag, this photoelectric effect is actually an instantaneous effect, that is an instantaneous process, as there is no time lag between the emission of electrons and absorption of photons, and hence this effect is an instantaneous effect. So with the help of an Einstein's equation, we also studied the different characteristics of photoelectric effect. Thank you.